PIG Part II. In this presentation, we are going to explore PIG commands that could be used with multiple relations. Okay, so starting with the join operator. So join operator supports both inner join and outer join. These are same concept that you find in SQL. Also co-group and union, split, and cross. So these are the commands. These are the operators that you can use with multiple relations. Okay, so let's start with join operator. So join operator is used when two data sets are used together, and basically it's joined through a common join key. Okay, so this is not that much different from join concept in SQL. So PIG supports both inner join and outer join, and inner join is the default. Okay, and in outer join you could have left outer join, right outer join, and full outer join. Again, this is pretty much the same in SQL. So let's take a look at each of these in a bit more detail. Let's start with inner join. So inner join, the rows are joined when the values of join key match between two relations, and rows that do not match are not included. Okay. By the way, inner joins ignore null keys, so usually it's a good practice to filter out the null keys before you perform joining. Okay, so as this picture is displaying, if you have two relations, inner join is representing the interconnected area. So let's see examples. So in this example, we have inner join simple, the PIG file, and if you see the contents of it, we have user data 1 text file, user data 2 text file, which is being read as user 1 and user 2. And as you can see, both data files has a common join key, in this case user ID, and users 1 has name and age, and users 2 has hobby and city. Okay, and so we are going to join. So if you see this line here, we are going to join users 1 and users 2 by user ID. So join users 1 by user ID and users 2 by user ID. So user ID is a join key. Okay, and then we can dump. So if you take a look at examples, so users data 1 text file contains 5 users. Okay, users 1, 2, 3, 4, 5, and the names and their age. Okay, and users data 2 text file again has a user ID, users 1, 3, 4, and 6, and it also users data 2 contains hobby and the city they live in. Okay, so Gulf and New York City and things like that. So when we join these two data sets using user ID as join key, what gets returned is, so when you run the PIG inner join simple.pig file, it will compare join keys. So there are users 1 and users 1. Okay, and what gets returned is users 1, so the data from the first data set, and data from the second the data set. Okay, and the users 3 also has a matched here, and users 4 also matched. Users 2 and 5 and 6, they do not have any matching, they do not match between these two data sets, so they are excluded. Okay, so basically, you know, this is what you are going to see. Make sense? Okay, so that is inner join. Now, field names in a join relation. So suppose if you want to make a reference to field names in a join relation, the way you can do that is you're going to use the name of the back name, and colon and field name. Okay, so let's example of this. So this is again the same data set that we have used in previous slides. So if you describe users 1 schema, so users 1 schema is user ID and name and age, right? Users 2 has a similar the schema here, so user ID and then hobby and city. Okay, now we perform the joining. Okay, now if you describe user info, which is a result of this joining, so that's what we have seen in previous slide. Okay, you can see the schema is representing. So here the first one is users 1 : user ID, and this is users 1 : name, and this is users 1 : age, and then this is the users 2 version of user ID, so users 2 : user ID, and things like that. So suppose if you want to actually select the columns of this join relationship, so suppose I want to select only, let's say, the name and hobby. Okay, and you could actually reference in this relationship using these names. So I'm going to use users 1 : name and users 2 : city. So I could use these references in my for each and generate the statement. Make sense? Okay. Moving forward. You could perform joining by using multiple keys. So in our example, we have used we did perform joining by using a single key like a user ID, right? But you could also use multiple keys. However, in this case, if you're using multiple keys, the number of keys must be the same, and of course the types of the keys must be the same. Okay, so that's kind of obvious. So let's see an example of this. So in this case, we are using users data 1 text file, so that is the same data set that we have used in our previous example. So user ID, name, and age. Now we are going to use a data 3 .text file as a second data. So in this case, it has a user ID and hobby and the age, city and age. Okay, so if I want to perform joining with the multiple keys, so instead of just using user ID, we want to use both user ID and age. Okay, so user ID and age and user ID and age. So both data set 1 and data set 3 have user ID and age fields. So we'd like to use a multiple keys, and they should be the same name, also should be the same type. So user ID is char-array and age is int. Okay, so in this example, we have users 1.text file. So this is the same data set we have seen before in previous example. Now this is the users 3.text file. So in this case, we have a user ID and the hobby and the city and as well as age. Okay, so in this case, both user ID and age has to match. Okay, so users 1 as 88, so this guy, this and this match. Users 3 also has same user ID and the same age. Okay, so when you perform, when you run this PIG script file, which contains this, you're going to have two tuples. Okay, one is users 1 and second one is users 3, because only two users 1 and users 3 have user ID and age matched. Make sense? Okay, so that is exercise 1. So let's take a look at the exercise 1. So we are performing inner join. So we are going to use, in fact, the same the data that we have seen in the presentation. So let's go to the Hadoop PIG 2 sample data. Okay, and let's take a look at user data text file. So these are the data set. We have a 4 user data set. Okay, so if you take a look at the user data set 1 text file, so this is the one that we have seen in the slide. Okay, same thing with data set 2 that text file. Okay, so And now we are going to, so so users data 3, this is the what you have seen. So here user ID, hobby, and city, and the age as well. User data 4 is user ID 11 and 12 and the age. Okay, so we're going to actually use users data 4 later on. Okay, so we are going to copy this user data files into my data directory into HDFS using copy from local. So I am going to just copy this command, and let's just copy into HDFS. Okay, and then I'm going to verify if those files are in fact copied, okay, into HDFS. Okay. Alright, so they are there, so they are copied. Okay, so now we're going to perform inner join. So if you take a look at the PIG script file of inner join simple, that PIG file, so oops, sample data. Oh, you know what, I should actually go to PIG directory. So this is incorrect. I go to sample pigs here. Okay, and if you see, we have a bunch of sample pig files. So just take a look at the inner. I'm gonna just copy inner join simple. So this is the one. So I want to just display the contents of it, and as we have seen in the slide, it's reading data text 1, data 2 text, and then we perform this inner join. Okay, so you don't see any inner because the inner is the default. Okay, alright, so let's actually run this guy. We are going to so you're going to just run pig, and okay, and eventually MapReduce and everything is going to get created, and the last statement is the dump. So what we should see is something like this. Okay, alright, so that's 1.1. Okay, and the 1.2 is we are going to actually play around with field reference using a shell, grunt shell. So you just run the pig in MapReduce mode, and then you are going to just describe users 1, users 2, and users user info. Okay, after joining is done. So user info is the joined relation. So basically, so I want you to in fact here, to select the name of the first relation, and then the city of the second relation, and so try that exercise. Okay, and the 1.3 is inner join with multiple keys. Okay, so the result is gonna be something like this, as we have seen in the slide. Okay, and 1.4 is now we can perform inner join with a function. So if you take a look at this, we are going to actually use user ID. We're going to actually use user IDs character 4th and 5. Okay, so in this case, when you run it, you are going to actually see anything user ID is let's see, user ID 4 and 5. So 4 and 5 is basically basically this one, R1 and R4. Okay, so it's pretty much the same result, I would say. Okay, but you can certainly use string, the other built-in functions to create join key. Okay, so this is the result. Okay, so I'm going to give you guys about let's say 8 minutes to try exercise 1. Next is outer join. So we just learned inner join. Now we are moving forward with outer join. So outer join, there are 3 different types of outer join. Left outer join, so as you can see on the left, this represents left outer join, and right outer join is representing interconnected and the second data set, and of course full outer join is it includes both data set on the left and right. So in this case, rows are joined when the keys match, so that is the same with inner join. The difference is that the rows that do not match are still included. So this is the difference from inner join. So in our case, of course this is the matched, and the things that are not matched in the left data set is going to be still included in the output. And right outer join, the right data set is going to be included. Okay, and full outer join will include both interconnected and also the ones that do not match. Okay, so let's see examples of this. So this is left outer join example. So here we have used the same data set, data 1, data 2, and then we are going to specify left outer. Okay, so note that we are actually using left outer with the users 1 data set. Okay, so the one that gets reflected is the users 1, users 1 relation here. So let's see examples. So this is the same data set we have seen before. Okay, so users 1, users 3, and users 4, those are the matched. So obviously they are going to be included. Okay, now the ones that do not match, in this case, red colored users, so users 2 and users 5, they do not match. Okay, however, they are still included. So note, when they are included, the ones on the right, they are all null. Okay, so this is left outer join. Okay, right outer join obviously is the other side. So here we are going to actually use right outer join, the users 1 and users. Yeah, so it looks like this one is, you know, it has nothing to do with these users and users 2. It basically will actually, you know, the syntax, this command is always right here. Okay, so in this case, the one that does not match in the second data set, users 2, will be included. Again, if you see the beginning of this tuple, they are null. Okay, so this is right outer join example, pretty straightforward. And of course, a full outer join is basically includes all the data set that does not match. So users 2 is from the data set 1, and users 5 is also from data set 1, and then user 6 is from data set 2. Okay, and the relevant part are all null. So that is full outer join example. Okay, so that is exercise 2. So exercise 2 is relatively straightforward. Okay, so this is the same example. So if you take a look at the outer join, so yeah, we are doing, this is the outer left join, and the result is going to be as expected like this. So these are all, you know, the same example code as we have seen in the slide. So I'm going to let you just do the lab exercises. Okay, so I'll give you guys about 7 minutes to try this exercise. Next topic is co-group. It's misspelled. Okay. So co-group creates a tuple for each key while preserving the structure of original data set. So this could be actually different. The difference from the joining. So here basically you can see this is reflecting the structure of original data set. Okay. Matching tuples from the data sets become a field in the new tuple. So you know these are the matching tuples from data set, and they become a field in the new tuple. You can also use the inner, and in that case only matched tuples are in the new tuple. So you can see these are the join key, and then it basically have original data from those data set as a bag. Okay, so let's see an example. So this is using same data set as we have used in inner join case, data set 1 and data set 2. And here we are using co-group, and we are using again the same syntax as joining. So users 1 by user ID and users 2 by user ID. Okay, so in this case, the structure that gets generated is going to be, so this is the user ID on the left. That is going to be the first column, and then the original data set will be captured as the value, and so in this case is a bag. Okay, you can see this is actually this is not inner join, so it actually includes so users 1, users 2. It's like a full join. It actually includes every user ID here. Okay, now if you want to have just the inner case, meaning then it will just display, it will just get only the users which has a matching user ID. So in this case, only users 1, users 3, and users 4. So those are 3 users that have a matching the user ID. Okay, so that is for inner case, inner co-group, and this is without inner. This is like a full join in a sense. Okay, so if you actually see the difference between inner join versus group and co-group, basically group and join operators perform similar functions. Group basically creates a single relation, by the way. Co-group is creating a nested set of output tuples, while join creates a flat set of output tuples. Okay, so that's the difference. So in this case, it's actually nested. Okay, you have the user ID, and then this is actually nested. While in joining, it's actually flat things out, right? Okay, as you remember. So that's the difference. Okay, so that is exercise 3. So let me just do the exercise 3 here. So this is simple co-group. This is the same example we see in the slide. Okay, so data set 1, data set 2, and then co-group, and what you're gonna get as an output is gonna be like this. Okay, and if you do use inner, then only in this case 3 users will be displayed. Okay, all right, so that is exercise 3. So I'm gonna actually continue the presentation, and then we'll have a lab time and probably lunch time as well. Okay, so that is co-group. Now let's talk about union, split, and cross. So union is merging the contents of 2 or more relations, and it does not preserve the order of the tuples. So both input and output relations are interpreted as unordered bags of tuples. So we'll see examples of that. And it does not ensure that all tuples adhere to the same schema or they have the same number of fields. Okay, so the tuples do not really have to have the same schema. Okay, in terms of types and in terms of number of fields. And it does not eliminate duplicate tuples. If there is in fact the duplicate tuple, it will be, both of them will be included. Okay. Split is partition the contents of a relation into 2 or more relations based on some expression. Okay, so we'll see that. And cross is compute the cross product, and it's a Cartesian product of 2 or more relations. Okay. By the way, just a comment. These, let's say, joining and co-grouping and union, splitting, and these things are in fact pretty important in the PIG, because as we learned yesterday as part of the introduction of Hadoop, Hadoop, the data set, they are not really created with the relationship with other data set, so as in the case of relational database. In the relational database, a table has, for example, has a foreign key to have a relationship with another table or join table. So the tables are in fact created with a relationship built in. In the case of the data set in Hadoop, data sets are just independent data set. So when you are actually creating a joint, so when you actually do some kind of a processing, that's the time you are going to provide the relationship using this joining and union and co-grouping and things like that. Okay, so it's a lot more flexible. So in fact, you might build this kind of relationship during runtime, and you have many different ways of actually creating this relationship. And this is the reason why we say in Hadoop, this is actually schema on read rather than schema on write. So schema on write is used in relational database. So when you write data, they actually has to be constructed in strict schema, including relationship with another table. But in the case of Hadoop dataset, there is no relationship with any other data type, data set, and a relationship could be actually built as part of the PIG script. Okay. All right, so it's actually quite common. You are going to use these relationship operators during when you're actually creating a PIG script, because you might in fact have a data set that collects the user information of their address information. Then you might in fact have another data set that contains their transaction history and stuff like that, right? So when you're trying to create to find out which customer in fact actually bought the most in the month of March or something like that, in that case you are going to use this join and union, whatever the operators, to construct a new data set, and then you're going to actually perform some operations to it. Okay. Alright, so this is union. So in this case, again, we are using data set 1 and data set 4. So this is the data set 1, the same data set we have used in previous example, and then data set 4 is using different user ID. Okay, so users 11 and users 2. I should actually another one like a users 1. Even if they are matching, they should be included. Okay. So now I'm unioning users 1 data set and users 4 data set. Okay, so in this case it will just include everything like this. Okay, so when you want to combine two data set, regardless of their structure, you can use union. Okay. Split. Split is to split a relation based on some condition. So suppose we have created union. So we have created union of user info, just adding data set 1, data set 4. Right? Now what we want to do is we want to separate out this users info data set, okay, combined of users 1 and users 4, based on the starting character. So if the starting character of the name, is S, I want to actually create a new data set. So first name start with S, relation is created with this condition, and first name starts with M is based on this condition, and this is first name start with the D. So you are going to in this case use a split command. Split user info data set, the relation, into 3 different data set, relation based on these conditions. So now if you dump first name start with S relation, then you're going to actually see only 2, because the Sang and Sarah, they are only 2 people who start with S as a starting character. Okay, and this is the data set 1 and data set 4. So that is a split example. Okay. Yeah, so this could be an example. Suppose if you have weather data that contains 100 of years of weather data. Sometimes you want to actually split it into per year. So you want to create the year 2001, year 2002. So based on year of based on year, you want to actually create a separate data set. Okay, so that's the time you could use, in fact, split command. Cross is crossing. So as you can see, we have a data set 1. Yeah, so this is the example. Cross users 1 and cross users 2, and basically, it's actually Cartesian product. So we have 5 the entries in the dataset 1, and we have 4 entries in dataset 2. So basically, we are going to have 5 times 4 the Cartesian product. Okay, so users 1 Sang Shin 88, and then this guy users 1 Gulf and New York City, and then users 1 Sang Shin 88, and then the second one users 3 streaming, and the San Francisco and things like that. So it's basically the number of the number of the data items in the data set times number of data items in the second data set is going to be the result. That's cross. Okay, so that is exercise 4. So let's take a look at the exercise 4. So here, yes, again, this is exactly the same example we talked about in the slide. So I'm going to let you try this as an exercise. So this is union case, users 1 and users 4, and it's going to result like this. Okay. I want you to add another, in the second data set, users 1 as well, and see whether that will be duplicated in the resulting data set. That should be okay. This is a split case, again same example, and this is a cross. And you can also actually use the cross and filter. So here we did a cross, and then we want to filter user info only when user ID and user ID matched. Okay, so in this case, what we are going to have is this 4, these 3 the cases. Okay. All right. So it's 10 minutes to 12. So I'm going to give you guys 10 minutes for exercise 3 and 4, and let's have a 30 minutes lunch time. So we are going to get back at 12:30. Okay. I'm going to be around, of course. So you guys, feel free to ask questions.